In this video, you will learn about some of the basic concepts of the circle. You'll learn some new vocabulary words, and you'll learn about some different relationships and theorems involving circles. So to begin, the first thing we want to talk about is a chord. Now, the definition of a chord is a segment joining any 2 points on a circle. So here's an example of a chord. Okay, because that segment is joining 2 points that are on that circle. So that's why this would be an example of a chord. It's connecting 2 points on a circle. Some other vocabulary that we've already talked about is the diameter of a circle. The diameter of a circle goes through the center point of the circle, and it connects 2 points on a circle. So notice a chord does not go through the center point. The diameter goes through the center point. Then the other vocabulary word that we've discussed is the radius of a circle. The radius is always half the distance of the diameter. So it comes from the center point of a circle to a point on the circle. Now, a theorem involving circles is circles that have the same radius, same size radius, are always going to be congruent. Or circles with congruent radii are going to be congruent to each other. Concentric circles, now this is a new vocabulary word, and if you look at the diagram below, that's an example of concentric circles. So what are concentric circles? They are circles with the same center point but different radii. So that's your definition of concentric circles. Now, the distance from the center of a circle to a chord is always referring to the perpendicular segment, since that is always the shortest distance. So the distance from the center to a chord is always referring to the perpendicular segment. So it's that perpendicular distance to the chord, from the center point to the chord. Now, keeping this idea in mind, there are 3 radius chord relationships that I want you to keep in mind throughout this chapter. And they kind of all sound a little bit repetitive, but it's just to kind of help you visualize this relationship here. So if a radius is perpendicular to a chord, then it bisects the chord. So if a segment coming from the center point is perpendicular to a chord, then it's going to divide that chord into 2 congruent segments. So that's something to keep in mind. If the radius of a circle bisects a chord, then it is perpendicular to that chord. So the reverse of that is true, but keep in mind that if a radius is bisecting a chord, that is not the diameter. So a diameter is technically considered a chord, but there's a fancy name for it because it goes through the center. So we're talking about everything but the diameter. So if a radius is bisecting a chord that is not the diameter, then it is perpendicular to that chord. And then finally, the last thing to keep in mind is that the perpendicular bisector of a chord always is going to pass through the center of a circle. So it passes through the center of the circle. So all 3 of these relationships kind of go together, and it's definitely a relationship that you're going to want to keep in mind throughout this chapter because you're going to see it used over and over again. We're actually going to be using it in some of the examples today. So go ahead and move on to the next video, and we're going to try some examples, keeping in mind these different theorems and relationships between the radius and the chord.